So we are here to discuss about the problem that is the Kadane's problem. It is basically a get interview. Uh, In some case, it may ask in the coding interview round. Problem is given that is we have given an array of size n, and we have to find the maximum sum of a subarray. And subarray should be continuous in nature. So coming to example, in order to understand the problem more. So the problem is the size of an array is given 5, and then array is given is 1, 2, 3, -2, and 5. What we have to do according to the problem that we have to find the sub array out of this array which has whose sum is maximum. So if we consider the sub array as only one, then the sum is 1. If we consider sub array as 1 and 2, then the sum of a sub array is 3. And if we consider the sub array of sum of 1, 2, and 3, then the sum of this sub array will be 6. And if we consider 1, 2, 3, and -2, the sum of this subarray will be 4. And if we consider all the whole array as a subarray, then the sum will be 9. And subarray can be of this one. Then the sum will be 5 plus 3, 8. That is 8 only. If we consider 3, -2, and 5, then the subarray sum will be 5 plus 3, 8, 8 -2, 6. And if we consider this, -2 plus 5, that will be 3. And if we consider alone 5, then the sum of will be 5. So we find out that the maximum sum of this subarray will be when we keep account of all the elements of an array that and then sum which we given is 9. Similarly, coming to this second example, n is given as 4, and the array we have -1, -2, -3, and -4. And what we have to find? We have to find the maximum sum. So the maximum sum out of this we know in negative numbers. The -1 is considered as the most maximum numbers, and the rest of the numbers smaller than -1 are -2, -3, -4. So here the maximum sub array sum will be -1 only. So we look at the some complexities that the time complexity is given is big O n and space complexity is 1. Okay. This is the function which is given to us. We have given an array and the size of an array. First of all, we will uh, use two variables, that is max u, which will give the maximum account till that particular position. Initially it's 0, and the max will keep account of the maximum of all the subarray which we have to find. Basically initially initialize this value to main dot value. Now we will go for a loop in order to traverse the array. So this is the loop, for loop for traversing the array. Now what we have to do, we have to keep account of each and every elements, whether it is contributing for the maximum array or not. So max util plus out of I, and when we find that the max value at certain position is greater than the official max value, then what we have to do, we have to just add that max till that positions to the max variable. And it may also happen that the max at that particular position is negative. and we didn't have to keep that negative account. So if we find that max at that particular position is less than 0, then the max total will become 0. And now we have to return it also. So after the for loop, we will return max. Let's check out if there is any problem. The code or not. What's given? Right? Okay. The code run. Now coming back to the problem. Let's suppose let's take an example of 1, 2, 3, -2 and 5. Okay. So first of all, the max view value is 0. The max value is also minimum value. Let we define that minimum value with at the rate. Here at the rate stands for minimum value. Now we traverse an array I equals to 0, means that max at u is equals to max at u plus AR of I. AR of I is 1, so max of I become 1. Max of I is greater than max, statement is true. Now the max value is 1, and as the max at u is greater than the max value, so max value also take the value of max u, that is 1. Max u is less than 0, the statement is false. Then we again go back to our loop and increment I plus plus. Now I will become 2. Then coming to max of I, max, and now the I value is 2. This one is 3, and as max is less than the max, you take up the new max value, that is it also become 3, and max is less than 0. The condition is false. We again increment the I value. Now the L value become 3. Now again max u equals to max u plus AR of I. Max u is 3 and AR of I is 3. 3 plus 3 is 6. Now max u is greater than max, the condition is true, and again the max take up the max u value. Now max u is less than 0, the condition is false. Now again we increment the value. Now the value of AR of I becomes 2. Max u is equals to initial max u plus AR of I, and 6 minus 2. What will the value is now? The value is 4. Max is greater than max, the condition is false, and max is also less than max, this condition is false. So again increment the value, the I value becomes 4, that is AR of I is now 5. Then max u is equals to max u plus AR of I. Now 4 is added with 5 to give us 9, and max u is greater than max, the condition is true. So again we increment the changes the max value to 9. This condition again false, the max is less than 0 as max is 9. Again we increment the value, now it come out of the loop as now is I is equals to 5. Now after coming out the loop, we have the return statement which return the max value. So this 9 values can return, and we get the answer as 9.